Welcome! In this video I will show you how to build the radial solutions to the hydrogen atom using two different methods. With one method we will use the Laguerre polynomials and the Laguerre associated polynomials to build them, and then in the other method we will use the recursion formula. So this will be based on Griffiths Problem 4.12 as it appears in the third edition of his book Introduction to Quantum Mechanics. So the problem states the following. It says, using this equation right here, work out the first four Laguerre polynomials, okay? And then that's just to get acquainted with the whole process of building them. Then using equations, well, basically these three equations, we want to find the polynomial v of rho, right? Which is the one that goes into the solution for the radial equation for the case n equals 5, l equals 2. And then we'll do that again, but using the recursion formula instead. So that's the plan for this problem. Now, let's begin with part A. Let's begin to learn how to work with Laguerre polynomials just a little bit. So we want to work out the first four. So first four, there we go. So the first one, of course, is L0. So L0, I'm going to be looking at this formula right there. This is e to the x. Now, zero derivatives of e to the minus x, x to the q, but q is 0. So this is simply 1, so well done, we did it. But unfortunately, not all will be so easy. So then we have L1, so L1 of x. And this will be e to the x. Now we have to take one derivative, so one derivative of e to the minus x, x. Okay, so this time it is x to the 1. So let's take this derivative. So this would be e to the x, and now we take the derivative. This would be minus e to the minus x times x plus e to the minus x, right? So here we're using the product rule. And now we multiply through, so the e to the x cancels out with the e to the minus x, so we end up with 1 minus x. Now we go for the next Laguerre polynomial. This is the third one. Keep in mind, it is the third because we started counting at 0. So this is e to the x. Then we have to take two derivatives of e to the minus x, x squared. Now don't get confused. It's not about taking one derivative and then two or something. You are taking derivatives of different objects. So you can't just take the derivative of this and think you will get the correct result. That's not the way it works. So let's take one derivative. So we have e to the x, and we have already taken one. And the result of that one is minus e to the minus x, x squared, and then plus 2x e to the minus x. Okay, so now let's take another derivative here. That would be e to the x. And here we get, let's see, so deriving the exponent, we get another minus sign. So we get e to the minus x, x squared. Then plus this same thing, but there's a minus sign. So we get minus 2x e to the minus x. So this part is ready. Then we get plus 2 e to the minus x. And then we have minus 2x e to the minus x. So here we can see we can add those two together. So instead of having 2, we get 4. So we get minus 4. And there we go. And then we just multiply through and the exponents cancel out. So here, arranging from smallest to highest power of x, we get 2 minus 4x plus x squared. Okay, so that is the third Laguerre polynomial. And then the fourth one, which is the last one that we will calculate for now, will be e to the x, dx, right? Three derivatives this time of e to the minus x, x cubed. Okay, so let's take one derivative. So this would be e to the x, and then we have still two derivatives. And the result after one is simply minus e to the minus x and times x cubed plus e to the minus x. Actually, I like to do it like this. So 3x squared e to the minus x. Okay, now let's do another derivative. So here we get derivative and then e to the minus x, x cubed, and then minus 3x squared e to the minus x. So we have done that. And then plus 6x e to the minus x, and then finally minus 3x squared e to the minus x. So by doing this, we can again add this with this, so we get 6. Okay, and now we can, well, go again. We have to derive one more time. So e to the x times, and now we have minus e to the minus x, x cubed, and then we keep this positive, so plus 3x squared e to the minus x, and then we go for this term here, so we get minus 12x e to the minus x, and then plus 6x squared e to the minus x, and finally from the last term we get 6 e to the minus x, and then minus 6x e to the minus x. So let's see, what can we simplify here? So we have 6 and 3, so that's 9. So this is 9, and this one goes away. And then we have minus 6 and 12, so that's 18. So this here is 18. And that's it. So now let's multiply through and arrange from lowest to highest power. So in lowest we have 6, then we have minus 18x, then plus 9x squared, and finally minus x cubed. So that is the fourth Laguerre polynomial. So that is part A. As you can see, not particularly difficult. There's a lot of integrations, so make sure to go step by step and not make any silly mistakes. Then is part B. So here we want to use these three equations to find v of rho. Okay, so let me just clear some space, or actually maybe let's just move everything to the side. Okay, so let's plug this in. So v of rho then, for the case n equals 5, l equals 2, is going to be the associated Laguerre polynomial here of 2l plus 1, so that is 5, and then n minus l minus 1, but n is 5, n is 2, so we have 5 minus 3, so that is 2. And this is a function of 2 rho. Okay, and then let's calculate the associated Laguerre polynomial for p, which is 5, and then keep in mind, q minus p is equal to 2, but we know that p is equal to 5, right? That thing right there is p. So p here is 5, so that means, of course, that q is equal to 7. So what we are calculating here is the associated Laguerre polynomial of 5 here, and just keep in mind, this is 5, 2, but q is 7, so keep that in mind. So this is minus 1 to the p, which is 5, and then we have to take p derivatives, so that's 5 derivatives of lq. And what is q? 7. So, oh my god, what have I gotten myself into? Well, make sure to leave a like on the video and all that, because I'm about to do something very annoying. Okay, so L7 of x, this is e to the x, 7 derivatives, God help me, e to the minus x, x to the 7th. Okay, take a deep breath, and let's begin. So this is e to the x, 6 derivatives of e to the minus x minus x to the 7th plus 7x to the 6th e to the minus x. So that is one derivative. Let's now go for the second one. So d dx 5, right? 5 more after this one. E to the minus x, x to the 7th, plus 7x to the 6th, e to the minus x, all that coming from here. Actually, there's a minus sign in front, so that's actually minus. And then we have this one, so that would be plus 7 times 6, so that's 42, x to the 5th, e to the minus x. And then we have one more here, so that would be minus, that's 7x to the 6th, e to the minus x. Is there anything we can add here? Yes, 7 and 7. So 7 and 7, that's 14. So we just put it there. So that's minus 14. Okay, let's go for the next derivative. So that would be d dx 4. So here we have minus e to the minus x, x to the 7th. minus, or rather plus, right? So that would be 7x to the 6th e to the minus x. Then we go for this part where we have minus 14 times 6 x to the 5th e to the minus x. And then we have plus 14x to the 6th e to the minus x. And then we have plus 42 times 5, which is 110, right? So that's, no, sorry, that's 210. So, whoa, 210 x to the 4th e to the minus x minus, things are getting very long now, minus 42 x to the 5th e to the minus x. Okay, so what can we simplify here? So we have to the 6th, we have 7 and 14, so that is 21. So this is 21. 21, I'm saying. And this one is bye-bye. Then we have to the 5th. So 14 times 6, that's 60, and that's 84. So we have 84 and 42. So that is 2 here, and then 126. So this is 126. So now I get rid of this, and I get rid of this. Okay, we're gonna get some very large numbers, my friends. Okay, so this is e to the x, and we are making some good progress. So one more derivative, let's go. Minus, so now we have plus e to the minus x, x to the 7th, and then we get minus 7x to the 6th, e to the minus x. And then we go for this part where we have plus 21 times 6 x to the 6th e to the minus x minus 21. Oh, that's not supposed to be x to the 6th. That's supposed to be x to the 5th. Minus 21 x to the 6th e to the minus x. And then we have, let's see, maybe I'll double check. So 1, 2. Yes, now comes this. Then we have minus 126 times 5 x to the 4th e to the minus x. Okay, and then one more, plus 126 x to the 5th e to the minus x. And of course we still need to include this one. So I'm just going to write it down here. So that's plus 4 times 210 x cubed e to the minus x minus 210 x to the 4th e to the minus x. Okay, so now let's see what we can simplify. So 21 times 6, that is 126. And that is, of course, the same amount that we have right here. So that is 126 times 2, which is 252. So bye-bye to this. Then we have, let's see, we can minus 7 and minus 21, that's minus 28. So this is minus 28. And then 126 times 5, that is 30. And then that's another 10, and that is another 10. So that would be, I don't know what I'm doing here. That was a disaster. That's 500 and then 600 and 630. Okay, it's 630. I don't know what I was doing there. So this is 630. So 630. And then I still have 210. So that is 840. So I'm just going to write it here, I guess. So that's 840. And that's it. Nothing else to simplify here. So let's get rid of this. And let's now go for the next derivative. So only 3 remaining. So now we have e to the x, dx squared, or rather 2 more derivatives after this one, minus e to the minus x, x to the 7th, and then plus 7x to the 6th, e to the minus x, and now comes this part, so we get minus 28 times 6, and that's x to the 5th, e to the minus x, plus 28x to the 6th, And let's now go for one more before I go to the next line. So this would be plus 252 times 5 x to the 4th e to the minus x, and then minus 252 x to the 5th e to the minus x. And now we go to the next line where I have these two. So that is 4 times 210, by the way, I didn't write that. That is 840. So that would be 840 times 3x squared e to the minus x, and then minus 840 x cubed e to the minus x. And then we go to this one where we get minus 840 times 4x cubed e to the minus x. And then we have, this is plus 840 x to the 4th e to the minus x. Whew. Okay, so we have 7 and 28, so that gives us 35. So goodbye to this one. Perhaps there's a pattern that you could see here, but I don't know. Then we have 28 times 6, so that would be 120 plus 56, so that is 176 in total, right? No, because 8 times 6 is 48. Yes, I did that wrong, so that's 48. So that's 168. I'm doing way too much math. I'm not good at this part. So that is 168. Perhaps I should start using a calculator soon. And then I have, actually I'm going to use, I don't want to make a dumb mistake and do this again. So let's just go there. So I have 252 plus 168 in negative, of course. So this would be 420. So this here would be 420. Then we have the x to the 4th here, which is 252 times 5 plus 840, which gives us 2,100. So 2,100. And we get rid of this. Then we still have these cubed ones, which is 840 times 5 basically, which gives us minus 4,200. So minus 4,200. Okay, so then we have e to the x. We have to take, okay, we are almost there, guys, just almost there. So another derivative, this gives us e to the minus x, x to the 7th, minus 7x to the 6th, and then e to the minus x. So that is this one. Now we go for this. So there we have plus 35 times 6x to the 6th, e to the minus x, minus 35x to the 6th. Wait, no, this is not right. This is x to the 5th. So that is x to the 5th. No mistakes here. E to the minus x. And then we go for this one. So there we have minus 420 x to the 5th. So if we put a plus here, we can use that as the exponent being derived. And then we get minus 420 times 5 x to the 4th e to the minus x. And now let's do the other three down here. So we get 2,100 times 4x cubed e to the minus x, and then minus 2,100 x to the 4th e to the minus x. Then we have this one where we get plus 840 times 6 times x e to the minus x, minus 840 times 3 x squared e to the minus x, and then finally minus 4,200 x cubed. We can put a plus here, e to the minus x, and the last part is 4,200 minus 4,200 times 3x squared e to the minus x. Okay, so let's begin with this. So that's minus 42 here, This is minus 42. Then we have the x to the fifth. That would be 35 times 6 plus 420. That is 630. And this one goes away. Then we have to the fourth power, we have 420 times 5 minus, or rather plus 2,100. So that gives us 4,200. So minus 4,200 x to the fourth e to the minus x. So goodbye to this and goodbye to this. Then we have the x cubed, which is 2,100 times 4 plus 4,200. That is 12,000, Jesus Christ, plus 12,600 x cubed e to the minus x. And then we have, okay, so this one I already considered. Then we have both of my x squares. So then we have 3 times 840 plus 4,200 times 3. So that is 15,120. And that is, of course, x squared, and with a negative, so minus this x squared e to the minus x. And finally, well, that other term. So now we have just one more derivative to clear. So the last derivative now, e to the x. Whew, so minus e to the minus x, x to the seventh, plus 7x to the sixth, e to the minus x. And then we have minus 42 times 6x to the fifth, e to the minus x, plus 42 x to the sixth, e to the minus x. Then we have plus 630 times 5 x to the fourth, e to the minus x, minus 630 x to the fifth, e to the minus x. And then we have minus 4,200 times 4x cubed, e to the minus x. Then we have plus 4,200 x to the fourth, e to the minus x. And then from this term, plus 12,600 times 3 x squared e to the minus x, minus 12,600 x cubed e to the minus x. And then from this we get minus, that would be 15,120 times 2 x e to the minus x, plus 15,120 x squared e to the minus x. And then let's do the last one here. So plus 840 times 6 e to the minus x, minus 840 times 6 x e to the minus x. Now we can put again all our terms together before we multiply through by e to the x. So let's see. So we have minus, actually, no, yeah, I'm going to do it like this. So minus e to the minus x, x to the seventh, then x to the sixth. So then we have 7x to the sixth here and 42 here. So that would be 49. So 49 x to the sixth, e to the minus x. Then we have x to the fifth. So this here and this here. So that would be minus, so that's 42 times 6 and 630. So that's 882. So minus 882 x to the fifth, e to the minus x. Then we have this and this. So that is 630 times 5 plus 4,200. So that's 7,350 x to the fourth, e to the minus x. Then we have this and this. So that is 4,200 times 4 minus, or rather, we just add them together and then put the minus sign, 12,600. That is 29,400 x cubed e to the minus x. Then we have our squares. So square there and there. So that is 12,600 times 3 plus 15,120. That would be 52,920. And yeah, and then we have x squared e to the minus x. Then we have this and this. So that is, are my signs correct here? Because one of them would be canceling the other out. No. That's because I'm supposed to add these two together. That's why. Okay, thank God. 840 times 6 minus 15,120 times 2. Sorry, I messed up. 15,120 times 2 and 840 times 6. So that would be minus 35,280 x e to the minus x, whoops, not that, sorry. And then finally, plus 840 times 6, 840 times 6, which gives us 5,040, and that's it. And e to the minus x. But now let's multiply through, so we get rid of every single e to the minus x. And there. And there you go. This is L7. So this is our starting point here. So now what we want to do is plug it into this formula, right? I'm gonna perhaps take it with me. There we go, Control C, and now let's just move back down so that I don't have to take my polynomial up. So what we now want to do, keeping in mind this thing here is L7, we just plug it in here. So we have to take 5 derivatives of this thing. Okay, now it may look scary, but it's actually not very hard, because if we're going to take 5 derivatives, that means that anything that has a power of x less than 5 will be 0. So all of these terms right there, all of those terms that are inside of this box are going to be 0. Because you're going to take 5 derivatives, eventually you're going to take the derivative of a number, and that's 0. So for our purposes, all that we care about are those first 3. So L to 5, this is minus 1, and then we want to take 5 derivatives of minus x to the 7th plus 49x to the 6th minus 882x to the 5th. And we don't care about anything else. So this would be minus 1 times, and now let's just derive 5 times. It's very easy because this is simply a polynomial. So we get minus 7 times 6 times 5 times 4 times 3 x squared, right? That's 5 derivatives. We just put the exponent down 5 times and we multiply by what is remaining here. Then we have plus 49 times 6, 1 time, right? Times 5 times 4 times 3 times 2. All right, there we go. And then we have minus 882, and this still has an x remaining, by the way. Minus 882 times 5 times 4 times 3 times 2 times 1, but no one cares about that 1. Okay, so, well, what is our polynomial here? Let's check it out. So this would be, well, first of all, let's multiply by minus so that we get rid of this. So this is plus, this is minus, this is plus. Okay, so then we have 7 times 6 times 5 times 4 times 3. That is 2,520 x squared minus, and then we have 49 times 6 times 5 times 4 times 3 times 2. That's 35,280 x. And then we have 882 times 5 times 4 times 3 times 2. And then this would be 105,840. Wow. Okay. So what is next? So now we found this, and finally what we have to do is just evaluate this at 2 row. Okay, and that's how we find v of row here. So now if we want to find v of row, we have to take this and evaluate at 2 row. V of row. Okay, so this would be 2,520, 2 row squared, and then minus 35,280 times 2 row. And then we have plus, well, this hasn't changed. Okay, so this doesn't look particularly nice. Perhaps there is some way in which we can simplify this. So let's see. So what we have here, let's factor some things out. So of course we can factor out 10, and that way we have 252 times 2 row squared minus 35,280 2 row plus 1058 4. Okay, so we made some progress. Now, what else could we do? Perhaps we can factor out, I'm just going to use a calculator here. Let's factor out, let's see, so let's factor out, try to factor out 16 or something. Let's see if we can do that. So 10,582 divided by 16, that's not a whole number. So perhaps by 8, so 10,584 divided by 8, that is a whole number. So let's factor out 8. So that would give us 80. And then this is 1,323. And then factoring out 8 here is 3528 divided by 8. That is 441. So minus 441 to row. And 252. That is not quite divisible by 8 unless we multiply here by 2. So 252 times 2 divided by 8, that is 63. So we have 63 times 2 row squared. So I borrowed one of these 2's so that I can factor out 8. Okay, so what can we do now? We can't really factor out 2's anymore. Perhaps we can factor out 3's. So to know if a number is divisible by 3, you just add the digits together, and if they add up to 3, then that number is divisible by 3. So these add up to 9, so that is divisible by 3. These add up to, that's 489, so that's also divisible, and 689. So all of them are divisible by 3. So this would be 240, and instead of 63, we have 21 to row squared, minus, now 441 divided by 3 is 147 times 2 row, and then plus, and this 1323 divided by 3, that is 441. Now that's the same that we had before, so that is of course also divisible by 3. This is divisible by 3, and that's 1112, that's also divisible by 3. So let's do it again. So 240 times 3, that's 720. So we would get here 7 times 2 row squared minus, so 147 divided by 3, that's 49 times 2 row, and then plus, and 441 divided by 3, that's, well, 147, of course, that's what we already calculated before. Okay, so now this is divisible by 7, this is divisible by 7, and 147 is also divisible by 7. So this would be 720 times 7, which is 5,040, factor of 2 row squared minus 7 times 2 row, and then, or 14 row, whatever, and then this here would be 21. So there we go. I guess I can just rewrite this quickly, so that minus 7 times 2, that's minus 14. So we just found v of row. So this is v of row for the case n equals 5, l equals 2. Now it was not particularly fun. I'm not gonna lie to you. I really don't want to do that ever again in my entire life. So let's now go to part C and let's take a look at the alternative. So now we want to find v of row for the case n equals 5, l equals 2, but this time using this recursive formula, keeping in mind that v of row here, this is simply going to be the sum, right, over I, which starts at 0 and goes to some maximum value, of ai times row of I. Okay, so that of course means this is a0 times rho to the 0th power, which is 1, so simply a0, and then plus a1 times a rho plus a2 times rho squared plus a3 times rho cubed, etc. And this will end at some point. And when is that maximum value? Well, that maximum value is when this thing is 0. And if you don't know where this came from, just go back in my playlist on non-relativistic quantum mechanics 1, and there you will see when we derive it, if you want to check that out. So the maximum here we find when n, right, the maximum power for rho is when n minus L minus 1, right, when this is equal to 0. Okay, so the maximum by power will come from this. So n here is 5. So we have 5 minus 2 minus 1. So this is 5 minus 3, which is 2. So our highest value will be 2. And after that, everything will be 0 once you plug it in this formula. I mean, then you get 0, and that's when it stops making sense. Okay, so with all that introduction, let's go. So A0 is, of course, A0. You have to find that from normalization. And then we have A1. So A1, this would be 2 times J plus L. So J in this case is 0, right? A1 corresponds to the case J equals 0. So 0 plus L, which is 2, plus 1 minus N, which is 5. And then we have J plus 1, which is 1, and then divided by 2L, which is 4 plus 2, so that's 6. So divided by 6. And this is times A0. So our first coefficient would be minus 5 plus 3, which is minus 2 times 2, which is minus 4. So minus 4 over 6 A0, or minus 2 A0 over 3. So that's A1. Now we only need to find A2. So A2, this would be equal to, and then we have, let's see, 2 times J, which is in this case, right, this corresponds to J equal 1. So 1 plus L, which is 2, plus 1 minus N, which is 5. And then we have divided by 2, which will cancel out with that. And then we have divided by 1 plus 4 plus 2, so that's 7. And this times A1. So here we have minus 1, so we get minus A1 over 7. And then, let's see, here we have to plug in the value for A1, which is this. So we have minus minus, so plus 2A0 over 21. So this means that our polynomial here, V of rho, would be 2A0 over 21 plus, sorry, so I'm not doing this in the proper order. I mean, it doesn't really matter that much, but A0 and then minus 2/3 A0 rho, and then plus 2A0 over 21 rho squared. Now notice, of course, we can factor out A0. So let's do that. So A0, A0, A0. So we can write A0 here and 1 minus this. And this is our polynomial. Now it's not the same as before, as you may notice. And that is, of course, because, well, we have not we have not normalized. We don't know what A0 is. But let's just multiply by 21 and divide by 21, basically factor out this 21. And that way we get A0, this would be over 21. And then we have 21 minus 21 times this would give us 14 rho, and then plus 2 rho squared. And now this looks a lot more like what we found, right? What we found before, oh Jesus, where is it? Here, 2 rho squared minus 14 rho plus 21. And there we go, 2 rho squared minus 14 rho and plus 21. The only thing we still need to do is find A0 by normalization. So you can see that we can't find the exact value here unless we then plug it into some wave function and normalize. But we don't have to do this massive, ginormous, terrible, atrocious derivatives. And yeah, I really appreciate not having to do that. So this really gives you an intuition why this recursive formula is so useful, because when you're going to those very high numbers, and we're not that high, it's only n equals 5, it gets really, really scary. So yeah, I hope that this video was useful to you. If it was, please make sure to leave a like on the video, think of my poor mental health, and also, leave a comment, share it with some of your classmates, and maybe consider checking out my Patreon. So I'll see you in another video. Thank you very much for watching.